Hi everyone, this is Marai Morsi and today I'm gonna show you how to optimize Docker images with Docker multi-stage builds. But before getting into action, why do we need multi-stages in the Docker file? So as you see here, this is not a typical Docker file. Usually we have a Docker file that has a single base image, but now we have two, or we could add more. So why do we have to in this example? So let's imagine in compiled languages such as Java, Scala, or Golang, we need a compiler, and then we need to compile a code in order to get an executable machine code. So you need to compile your code first, but when you add the compiler and all the runtime inside the Docker base image and you build it, you will get eventually a very huge Docker image. But what if we could just get the executable file and use simple base image like BasyBox or Albine? You would get a much smaller image, and the main reason why we are doing this is in order to get a lightweight production ready container. So let's get into action. So here is a very basic Golang web server, and here is the Docker file that builds it. It uses the Golang base Docker image, and we copy the code file and we compile it. That generates a web server executable file, and this is what we really care about. So let's build it. Docker build. Let's give it a tag as web server, and let's build it in this context. Wow, it got built lightning fast. So let's see what size this image have. Docker images, and let's grab the web server. The size of this Docker image is 971 megabytes, which is almost a gigabyte. This is huge, and we need to reduce this in order to have a lightweight production ready container. So this is why we really need to use Docker multi-stage build. So we are gonna need two stages. The first one is gonna build the code and generate the artifact, which is the executable file. Then we pass it to the next stage, which has the light base, which generates a very lightweight production ready container. Here is the first stage. Let's give it a name as, let's call it the build stage. Since we are gonna build it, there is no need to use those. Let's use the lighter base, which is I'm gonna use a very lightweight base image like BasyBox or Albine. So from Albine, I'm gonna need a working directory, and it's gonna be /app. Then we are gonna copy the artifact, so we need the copy, and but we need to say -- from and pass the stage. The stage we are gonna take the artifact from is gonna be build, and the source is gonna be /go/source/app with the name of web server, and the destination is gonna be our destination here, which is /app/web server. So here we go, let's build it. So I have the Docker build, but I'm gonna give it a tag like reduced, and let's build it. Let's see the size of the reduced image. Wow, this is so small compared to the non-reduced one, which is the Golang base image. It dramatically reduced the Docker image size up to 10 times. So this is huge. and we could also reduce it even more, like we could build it from scratch, but we will get rid of some useful functionalities like debugging and shell. So it's a trade-off, and I'm pretty satisfied with this result. So this is one of the use cases that demonstrates the power of using the Docker multi-stage build. Thanks for watching.